Hello friends, welcome to our channel, Gajpal A Learning. In this video we are going to start another topic of pharmaceutical analysis, that is gravimetry. Under this, introduction to gravimetry, precipitate, precipitation, gravimetry and types of the precipitate. So let's start the video. Gravimetry. Gravimetry in the context of pharmaceutical analysis is a quantitative analytical technique used to determine the concentration or purity of a substance by measuring its mass. This technique relies on the principle that the mass of a substance can be related to its chemical composition, allowing for precise quantification. Here's how gravimetry can be applied in pharmaceutical analysis with an example. Example: determination of the purity of a drug compound. Suppose you have a powdered drug compound, and you want to determine its purity by gravimetric analysis. Here's how you might carry out the analysis. First, weighing. Accurately weigh a sample of the drug compound. Let's say you have a 1.000 gram sample. Second, sample preparation. Dissolve the sample in a suitable solvent to remove any impurities or contaminants. This step may involve chemical reactions to separate the compound of interest from other substances. Third, precipitation. Add a reagent to the solution that will react specifically with the drug compound, forming a precipitate. The precipitate should be of known chemical composition. Fourth, filtering. After the precipitate has formed, carefully filter it from the solution using a filter paper or a filtration apparatus. Fifth, washing. Wash the precipitate with a suitable solvent to remove any remaining impurities or the original solvent. Sixth, drying. Dry the filtered precipitate to remove any residual moisture. This can be done by heating the precipitate to a constant weight. Seventh, weighing again. Weigh the dried precipitate accurately. Let's say the dried precipitate weighs 0.800 grams. 8th, calculation. Calculate the percentage purity of the drug compound using the formula. Percentage purity equals mass of pure drug divided by mass of sample into 100. In this case, it would be 0.800 grams divided by 1.000 grams into 100, that gives 80%. So, based on the gravimetric analysis, it is determined that the drug compound is 80% pure. Gravimetry is a valuable technique in pharmaceutical analysis because it provides accurate results when properly executed, allowing pharmaceutical companies to ensure the quality and purity of their products. Next is precipitate. A precipitate, in chemistry, refers to a solid material that forms when two or more substances, typically in a solution, react chemically and produce an insoluble or sparingly soluble compound. Precipitates are formed as a result of a chemical reaction called precipitation, where the dissolved ions in a solution combine to create a solid that is no longer soluble in the solvent. Precipitates often appear as fine particles or solids that settle at the bottom of the container or remain suspended in the liquid. The formation of a precipitate is typically observed when two solutions are mixed, and a reaction occurs that leads to the formation of an insoluble compound. This can be due to a variety of chemical reactions, including precipitation reactions, double displacement reactions, or acid-base reactions. Precipitates are important in various areas of chemistry, including analytical chemistry, where they are used for qualitative and quantitative analysis, and in various industrial processes and research applications. They can be collected, filtered, dried, and weighed for further analysis or to isolate specific compounds from a mixture. Now, precipitation gravimetry. Precipitation gravimetry is a classical analytical technique used to determine the concentration of an analyte, the substance of interest, in a sample by selectively precipitating it from a solution as an insoluble solid compound. The mass of the precipitate is then measured, and from this mass, the concentration of the analyte can be calculated. This technique relies on the fundamental principle that the mass of a substance can be related to its chemical composition, making it a valuable method for quantitative analysis. Here's a step-by-step explanation of how precipitation gravimetry works. First, sample preparation. Start with a sample containing the analyte of interest, typically in the form of a solution. The sample may contain impurities or other substances that need to be removed or separated. Second, precipitation. Add a carefully selected reagent, precipitating agent, to the solution. This reagent should react specifically with the analyte to form an insoluble precipitate. The choice of reagent is crucial, as it should produce a precipitate that is easily filterable and has a known chemical composition. Third, Formation of precipitate. The chemical reaction between the analyte and the precipitating agent results in the formation of the insoluble solid precipitate. Fourth, filtering. Use a suitable filtration method to separate the solid precipitate from the remaining solution. This can be done using filter paper, a filter funnel, or other filtration apparatus. Fifth, washing. Wash the collected precipitate with a suitable solvent to remove any traces of the original solution or impurities. This ensures that the precipitate is pure and of known composition. Sixth, drying. Dry the washed precipitate to remove any remaining moisture. This is typically done by heating the precipitate to a constant weight. Seventh, weighing. Weigh the dried precipitate accurately using a balance. The mass of the precipitate is directly proportional to the amount of analyte present in the original sample. Eighth, calculation. Calculate the concentration or mass of the analyte in the original sample based on the mass of the precipitate and the stoichiometry of the reaction. This calculation allows you to determine the analyte's concentration or purity in the sample. Precipitation gravimetry is widely used in various fields of chemistry, including analytical chemistry, environmental analysis, and pharmaceutical analysis, to determine the concentration of specific ions or compounds. Its accuracy and reliability make it a valuable technique for quantitative analysis, provided that careful and precise laboratory techniques are employed. Next is types of precipitate. Precipitates can vary in their characteristics and formation mechanisms, and they can be classified into different types based on various factors. Here are some common types of precipitates. First, crystalline precipitates. These precipitates have a well-defined, regular crystalline structure. They often form when reactants combine in a specific stoichiometric ratio. Examples include the formation of silver chloride, AgCl, from the reaction between silver ions, Ag positive, and chloride ions, Cl negative. Second, amorphous precipitates. Amorphous precipitates lack a well-ordered crystal lattice structure and appear as irregular, non-crystalline solids. Their formation is typically less controlled and can be influenced by factors like temperature and rate of precipitation. An example is the formation of gelatinous AlOH from the reaction of aluminum ions, Al positive, with hydroxide ions, OH negative. Third, colloidal precipitates. These are very fine, finely divided solid particles that remain suspended in a solution due to their small size. They do not readily settle out like typical precipitates. Colloidal precipitates have a large surface area, making them useful in various industrial applications. Examples include colloidal silver or gold nanoparticles. Fourth, gelatinous precipitates. Gelatinous precipitates are soft, jelly-like, and have a high water content. They often form when a precipitate is not thoroughly washed or dried. Gelatinous precipitates can be challenging to handle and analyze. An example is the formation of gelatinous FaOH3 when iron ions, Fa3+, react with hydroxide ions, OH. Fifth, crystalline mixtures. Sometimes, precipitates may consist of a mixture of two or more different crystalline compounds. This can occur when multiple reactants are present in a solution or when a reaction produces multiple products. Analyzing and separating such mixtures can be more complex. Sixth, single salt precipitates. These are precipitates consisting of a single chemical compound with a defined chemical formula. They are relatively straightforward to characterize and analyze. Seventh, double salt precipitates. Double salts are compounds that contain two different cations and/or anions in their structure. Precipitates of double salts may form in reactions involving compounds with multiple ions. A well-known example is the formation of alum, KAlSO4, 2.12H2O2 in certain chemical reactions. The type of precipitate that forms depends on factors such as the chemical composition of the reactants, the stoichiometry of the reaction, temperature, pH, and the rate of precipitation. Accurate identification and characterization of the precipitate type are essential in analytical chemistry and various industrial processes to ensure the desired outcome of a chemical reaction or separation. Thanks for watching this video. If this video was helpful, then kindly please subscribe to our channel. Thank you.